Python Essentials 2 Module 3 test. The first question, what will be the output of the following code? Class A, and we have a class attribute defined as the same name, the capital A equals 1. And we need to print whether this class A has an attribute which this name is passed as a string. As far as I understand, I recall the Python will allow you to do that. So it is possible to have an attribute named exactly as the class, and it is an attribute, so this should return true, and true will be printed in the console. What will be the result of executing the following code? We have class A with an attribute. We have class B, which is a subclass of A, which redefines this attribute. We have class C, which is a subclass of B, which doesn't define anything. What we do, we instantiate an object of class C, and we print the attribute V from that object. So what will happen here, it will check whether this attribute, first of all, exists in the object itself, and it is not, because there is no any instance attributes named V. The next thing, it will check whether this exists in the class of this object, and this is C, and it will not be able to find it there because there are nothing. And then it will go upwards to the inheritance chain. And next it will check the class B, and it will find the value V there as 1. So 1 should be printed in the output. What will be the result of executing the following code? Okay, so we have class I defined here with init, iter, and next methods. So we are trying to build an iterable here. What we do with it, we do for in this class, so it will create an instance of this class. The init will work to create an instance, and then iter will return the object self as it is required by the iterable protocol, and then next will be called. So let's see how init will initiate. It will initiate with the instance variable ABC, and I is presumably the index is 0. Okay, so iter is not interesting. Let's see what happens in the next. If self I equals length of self S, so if we are at the end, we will raise stop iteration exception, and this will stop the iteration. Okay, clear. This is the stopping condition for the iteration. Then V equals self S with this self I index, which will start with 0. And then this index just increases by 1. And each time we return the value we have taken. So it will basically print ABC. It will return A, B, and then C, respectively, in the iterations. So it will print ABC, should be the correct answer. What will be the result of executing the following code? We have class A, which defines the stir method to describe this class as a string, and it just returns A. We have class B, which defines another method, its own stir method to describe itself, which returns just the string B. We have class C, which inherits from both A and B, and it does nothing. And we create an object of class C, and we just try to print it. So what will happen here? First of all, it will try to find the stir method like that with dunders in the class itself, and it will not find it there. And then it will go over the inheritance structure. In this case, we have kind of two options. We have two parents for this class, and it will just go left to right. So first thing, it will check within the class A, and it will find the stir method there, which will return A, and that will be printed in the output. So the correct answer is it will print A. What will be the output of the following code? class A, we have a class attribute equals x equals 0, and we have init defined. Okay, let's see. A is an instance of that class. Okay, this instance is created. What happens when this is done? So a dot y is defined, right? The y in this case is the instance variable, and it is defined as 0 because we are not passing any argument here, and it will take the default value from here. Okay, and then I will put it in elsewhere. So a point x, which is this variable, it will be incremented by this value. So it will be 0 plus 0 equals 0. Okay. So so we are done with this. The next thing is we create another instance of this class, right? With 1. So what will happen? There will be created an instance B, and this instance will have its own instance attribute y, which will be equal to 1 because this is the parameter we pass over here. Okay. But another thing it will do upon its initiation is it will perform this operation. So, and this of course is just class variable, so it is common for all instances. So it will increment the current value 0 by the value of v, which is 1. It replaces the 0 with 1. We are done with this one. And then the next we go with C. We create an instance C, and it also has its own attribute y, which will be set as 2. And likewise, it will also affect the class variable a.x. It will add 2 to it, and it will replace 1 with 3. The next thing is that it prints c.x. And because it is a class variable, it is also shared by all the objects or all the instances of that class. So whether we print a.x or a.x with a small a, or b.x or c.x, it's all the same. It's all the same value of 3. So the correct answer here should be 3. A data structure described as LIFO is actually it is a stack. So last in, first out. The last item we put on top of a stack, which may already have some other items, and it will be taken out the first. Last in, first out. It's a stack. What will be the result of executing the following code? We have class A defined with a method A, which prints A. Okay. We have class B defined, which has also a method A, which prints B. So these classes are not dependent. They are independent from each other. And we have class B, which is a subclass of both B and A in this respective order, which defines a function C or method C, which calls self.a. Okay, let's see what's happening here. We create an object of class C, okay, this one, good, and we call this function. So what will happen when this function is called? It will call self.a, right? So the first thing it will do, it will look for that method A in itself, right? And there is no such method there. The next thing it will do, it will look in the inheritance structure, and it will first look on the leftmost class listed here, which will be class B. And this class B does have the method A, and this will print B. So there will be no A printed. It will just print B. What will be the result of executing the following code? So what we have classes which do not define anything in them except of themselves. We have class A. We have class B, which is inherited from class A. And we have class C, which is in its order a subclass of B. and we print is subclass C of A. Yeah, so basically it's a very simple question. In this case, will class C be a subclass of class A? The answer to this question is yes, although it is not a direct child of class A, it is still a subclass, right? Indirectly. What will be the result of executing the following code? Class A, we have the constructor. We create an object of class A with 1 here, and print has attribute A. Okay, I see one problem here. In the class methods, should be always be indicated the self parameter to kind of take the objects itself inside the method and to be able to work with the object properties and other methods. But here we are calling this with a parameter. So then for this to work, there has to be some other parameter here indicated, which would be able to take in this value of 1, and then this value can be processed. So this code is overall is erroneous, it will not work, and it will raise an exception. What will be the effect of running the following code? Class A define the constructor with self, and in this case we have the parameter of v, and this class defines a private variable because it's a dunder over here, which increases this parameter by 1. So let's see what will happen. A is constructed with the 0, and this will be this private instance property or attribute will have the value of 1, and then what we do, we try to print it. So this will not work, okay, because this idea of this dunder notation is to make this attribute private. It is at least a very strong indication from the programmer who created this class that, hey, you're not supposed to access this variable directly, okay? There is a way, however, to do that, right? Because there is the what Python actually does at stage of the interpretation. It converts all the method names and property names, which are written this way with the dunder, into something which would look in this case like 1_a, which is the name of the class, then $_ a. Okay. So in this case, it would be, even although it is private, we will be able to access this and print it if we try to access this way. However, it is sort of a hack, right? And you're not supposed to do that. And anyway, so this notation will not work, and this will raise an exception, and this will be the attribute error exception because there is no such attribute in the instance. What will be the result of executing the following code? Okay, we define a function where we have try x equals x divided by x. We call this function with 1, we call this function with 0. Okay, very simple. The first time we call it, we just do 1 divided by 1. We put the result in x, which will be 1. And there is no exception. However, what it will do, it will print the finally, right? Oh no, it will also do the else, right? So else is executed when there was no exception. So it will print B, right? And finally is executed no matter what, it is always executed. So this will print C. So this is for the first call. And then there is the next call with the 0. We will try to divide 0 by 0. This will throw an error, which will be caught in the except block over here, and this will print A. And then else will not be executed, but finally will again be executed because it is executed no matter what. So what we will have printed is BCAC, and this is that option. What will be the result of executing the following code? We try to raise an exception with 3 arguments right away, 1 to 3, and then we access these arguments as the args property of the instance of the exception class. So args is actually a standard property of the exception class, and it is a tuple which contains all the values which were passed into the exception. So in that case, this tuple's length will be 3, and the correct answer is 3. What will be the output of the following code? We have class A, which has a constructor with a parameter, and it initiates the instance variable v here. Okay, and there is also the set method, which can just change this value v to whatever is provided. What we do, we create A as an instance of this class, and this will initiate v as 1 because the value is not passed here to the constructor. So it will take this default value over here. So v will have the value of 1. And then what we do, we take this value a.v. We can perfectly do that, no problem with that. This will be 2, right? Because it is incremented by 1. And we set it there, okay? And the set function, what it does, we don't even have to care what this instruction does because it doesn't matter, right? It just takes this value here as 2, and it just returns it, right? It doesn't even change it. So this line here even doesn't matter at all. And the 2 will be printed in the output. In the class constructor, if the class constructor is declared as below, which one of the arguments is, which one of the assignments is valid? Okay, let's see. Class is the name of the class is okay, no problem with that. This is a perfect definition of parameterless constructor. So object should be initiated only that way, right? Without passing any parameters in the parentheses when we call for this for an object of this class to be created. No self, no object, but you have to indicate the empty parentheses. What will be the result of executing the following code? We have exception defined, and it is a subclass of a standard class exception. We redefine its constructor, and there is message to be passed there. Exception init. So we call the superclass method init with this message doubled. Okay, for no reason at all, but okay, if we want to do that, no problem. And then we set self-args as the tuple of this message. Okay, let's see step by step. We just do raise this exception x with x. So what it will do, it will put it here, xx, right, will be passed into the constructor, and this superclass constructor will set these, it will set this as its own internal property, right? And I am not sure, I don't believe that the internal property name is MSG. How will we know it? Not sure. Anyway, so it sets the self-args as this message. So this will be a tuple of just one string, x, like that. Right, so this is a tuple. And what it will do, it will catch it here, x. It will not catch it here because it will be caught before, so the standard exception handler will not work, and it will just print it. Okay, interesting. So then when we call the superclass, the exception superclass, constructor, okay, this one will just do the self args. Yeah, I don't think it will double the x. I feel more like it will just print x. Okay, because no matter what the superclass constructor does, which is kind of storing a duplicated message XX, it will store it there, but these args will, yeah. So this class, our class, will kind of store it in the args attribute, and what string or str method does when it is called, and it is implicitly called over here when we call to print this instance, it will just take the args property and convert it to string and will print it. Okay. So I believe that this will print just X. I'll go with this option. If there is a superclass named A and a subclass named B, which one of the presented invocations should you put instead of the comment? Class A, class B, we have the constructor here, which initiates self A, and B is a subclass of A, and it redefines the constructor. Which one of the presented invocations should you put instead of the comment? So I assume we want to call the superclass constructor within our subclass constructor and then do some additional steps. No problem with that. So it is basically a question of how to properly call the superclass constructor within our class constructor. And it is done in that way, I believe. So because the superclass constructor doesn't have any parameters, there is only one implicit parameter, self. When we call it, we do not need to pass any parameter to it. I believe this is the correct option. Yeah, we still need to specify the class name, the superclass name here, and then the method, and then no parameters. That should be the correct answer. What will be the result of executing the following code? We have class A, we have class B, which is a subclass of A, and we have class C, which is a subclass of B. So we have a chain here. We create an object of class C and we print it. So whenever we try to print an object, the standard str method will be called. What it will try to do, it will try to call the class C method first. It will not find it here because it's not there. And then it will look for and it will find this method in the parent class A, and that should print the string B in the output, and it will not get to class A at any point. So that should print B over here. That was the last question. Let's check for errors. Okay, let's review. So we have, I will scroll through the questions to find the error. There should be just one. Okay, this one. Okay, so this was the question number 16, and it is about how to invoke the superclass constructor from our class constructor, and this is not correct. So let me see. Okay, so what I have found in the course, and this is a little bit kind of detail, with important detail, but kind of still detail. There are, of course, two ways to call this superclass. You can use either explicitly the superclass name. So in this case, we have a superclass, we have a subclass, and we call the superclass method from our class constructor this way. So we call super, which is the name of the superclass, init And then if you invoke it this way, you must also pass self here. Okay? However, why I got confused, if I scroll to the next page, there is also another way, which is the super method, right? And this is another way to invoke the superclass. And I think this one is even kind of more recommended way to do that because it's more universal. So you just exactly the same line. You call super, and then you call init, and then you pass the parameter, and you do not indicate self here. So whether you need to include this self in this superclass constructor call depends the way you address this superclass. If you call it explicitly, you must include self. If you use super for it, you must not include the self here, which is I have no idea why, but that's the way the things work. So because we are explicitly calling the class superclass name here, we must use self and pass it in the as the argument. So that option over here should be the correct answer.